So in my last video, I was showing how to superimpose both the histogram and the related line graph from a frequency distribution. The one that we were doing in class was was looking at the ages of the presidents, the last 25 presidents that took office, excluding President Biden. I'm going to turn that data off. Stat plots, that is, for those data plots. And you can go into stat plot and push on the stat plot that you want to turn off and cursor over. And just because it's flashing off doesn't mean it's off. So you do have to push enter to turn it off. And you'll notice if I push the Y editor that plot one does not have a highlighting on. The faster way to turn a stat plot on or off is to just hover up to that stated plot. And if I push enter, it turns it off. If I push enter, it turns it on. So that's a real quick way to toggle it on and off. Now, if I push graph, no, we don't see a line graph nor a histogram. What I want to do next was show you the data that I have in list 5 and list 6. And this relates to the information in section 2.4 on correlation. So in list 5 and list 6, I have the lengths of 20 randomly selected males' feet. And in list 6, it's that male's height, both in centimeters. If I want to see a scatter plot of the values in list 5 and list 6, I'm going to again use a stat plot. So I'm going second Y editor, and I'm going to scroll down to plot 3. And I'm going to turn that on, and I want that data to be scatter plot of the values from list 5 and list 6 for my X and Y values. So I scroll down. The first graph type in this stat plot editor is a scatter plot. So I'm going to go down and push second 5 to paste L5 for the X values of these points, and second 6 for the data for the heights. List 5 had the foot lengths of the males, and list 6 had their related heights, both in centimeters. I can choose what kind of mark I want and what color. So if I push zoom stat, again, zoom 9, it will plot the data. Now, sometimes I might want to modify the window settings so that I can see maybe the x-axis. But in this case, because we don't have anybody's heights or lengths of feet that are close to 0 centimeters, you may just ignore putting some buffer to show the axes. Here, if I put, let's say, for instance, -5 up to 30 for my x-min and my x-max, and I'll do that in jumps of 5, and I want this to go from, let's say, -20 to 200 in jumps of 10. Now that those window settings will change where the graph starts from left to right and bottom to top. It's just that all of the scatter points are way up in the top right-hand corner. So I'm not sure if that was definitely was very helpful. Sometimes it's helpful and sometimes it's not to show the X and the Y axis. If I push zoom and over to memory, I can push enter, and I went back to the home screen so that if I zoom 9 it, that's back to the scatter plot. If I want to compute the Pearson Correlation Coefficient on this data, I'm going to go back to the home screen and go into the stat editor. And I want to go over to calculate. And if I scroll down to linear regression, option 8, I want to perform a linear regression on the data in list 5 and list 6, which are the male foot lengths and their heights. So I've put L5 there for the list, and I'm going to scroll down to the Y list, which is list 6, and I'm just going to leave the frequency list blank, and I want to store the regression equation maybe into my Y editor so I can graph it. So I have to push vars over to Y vars, function, and 1, or enter, paste Y sub 1. So now when I go down and execute the calculate, it tells me the slope and the y-intercept for the line of best fit. And if I go to my Y editor, that function, that linear function, has been placed into Y sub 1. So if I push graph, you'll see the line of best fit. Now, this is a little tricky, but if you push second 0 in your catalog, if you go all the way down to diagnostics, the Factory settings have the diagnostics off. So if I change diagnostics off to diagnostics on, it will show the Pearson correlation coefficient. So I'm going to paste the diagnostics on command to home screen, execute that, and push second entry twice to go back to the regression on list 5 and list 6 that stored the function into y sub 1, specifically the linear regression. This time through, when I do it, I'm also shown this R value, which is the Pearson correlation coefficient. And if you remember in class, that's what we got, 0.6516, when we did this in Excel. So you can get the Pearson correlation coefficient, plot the scatter plot, graph the line, and even know the equation of the line. Of course, you might want to shrink down the accuracy of this value by maybe only going to the closest hundredths. Delete irrelevant decimals so that that function doesn't look so obnoxious. So here I have to round that 6 to a 7 and then get rid of all the other decimals for the slope. It doesn't really going to change the look of the line. So that's pretty cool.